Here we have a pre-calculus question. Okay, let's go with the question. The expression log b to the base a positive 4 times log ac to the base a negative 4, where a, b, c greater than 1 written as a single logarithm. So we have to write this expression as a single logarithm. Okay, let me write the expression as it is. That is log b to the base a positive 4 times log ac to the base a negative 4. Okay, so in my first step, what I'm going to do is I'm going to use the power of logarithm over here. So because here this logarithm is multiplied by 4, so whenever a logarithm is multiplied by some number, the number multiplied in front of the logarithm can be taken as exponent for the argument. So this is the power of logarithm. Then I'll be getting log of ac to the 4th power to the base a negative 4. Okay, here the two logarithms are in addition with the same base a. I can use a product rule. So whenever two logarithms are in addition with the same base, we can take logarithm ones with the base what we have for the two logarithms, and we have to multiply the arguments. That is b times ac to the 4th power negative 4. Okay, let's simplify. Okay, b times, here a and c are multiplied and we have the common exponent 4. So whenever two values are multiplied and we have the common exponent, we can distribute the exponent to each value and multiply them. Then I'll be getting a to the 4th power times c to the 4th power negative 4. Okay, now here we have a logarithm and a number are in subtraction. So how can we do? How can we simplify this expression? Okay, so for that, what I'm going to do is I'm going to write this number 4 in terms of a logarithm with the base a, because I'll do the first logarithm over here as base a. So I have to write this number 4 in terms of a logarithm with base a. Okay, let me do it. Log to the base a. So that can be this can be written as a to the 4th. I mean b times a to the 4th power, c to the 4th power negative. I assume this 4 is multiplied by 1. Even if I assume there is 1 multiplied by this 4, the value will not change because 4 times 1 is still 4. So in mathematics, to get the answer, we can do anything, but the value of the original stuff should not change. Okay, I've written this 4 as 4 times 1. So in my next step, what I'm going to do is log to the base a, b times a to the 4th power, c to the 4th power negative. Instead of this one, I'm just going to write a logarithm whose value is equal to 1. So that can be done by writing log a to the base a. So because in a logarithm, if the base and argument are equal, so its value is 1. So instead of this one, I'm writing log a to the base a because its value is just 1. So here we may have a particular question. Why should we write this particular logarithm for 1? Even we can write the log b to the base b, or log c to the base c, or log 2 to the base 2. So the reason why I'm writing this log a to the base a for this one is, so for the first logarithm we have base a, so the logarithm which I'm going to write over here must have the same base so that I'll be able to simplify. And also one more thing we have to notice here. Let's consider a logarithm whose argument is 1. So what is the value of this logarithm? Its value is 0. So what is the, actually I have not mentioned the base over here. You may have any base. So if the argument of logarithm is 1, so the value of the logarithm is equal to 0. So what if for log 1 to the base 1? Even if the base is 1, it is equal to 0. So log 1 to the base n equals to 0. The reason is the argument of the logarithm is 1. So the value of this logarithm is 0. Except this case, let's consider some other case, log 2 to the base 2. Log 3 to the base 3. So its value is 1, 1 because the base and the argument are same. Here the base and the argument are same. So here also we have written the base and argument are same. So we have to make sure the argument should not be 1 so that the value of the logarithm will not become 0. So how can I make sure that the value of a is not equal to 1? Because the question clearly says all the three values a, b, c greater than 1. So the value of the logarithm I have written over here equals to 1. So because a is not equal to 1 and also the argument and base are same. So the value of this logarithm equals to 1. So in case even in this logarithm, if a equals to 1, the value of this logarithm will become 0. But that's not possible in this case because a is not equal to 1, a is greater than 1. So the value of this logarithm is, log a to the base that I have written over here equals to 1. Okay, now let's continue the simplification process further. So log to the base a, b times a to the fourth power c to the fourth power negative. So here there is a number 4 multiplied in front of logarithm. So using the power rule, this 4 can be written as exponent of the argument a. Then I'll be getting log a to the fourth power to the base a. Okay, here two logarithms are in subtraction with the same base a. So whenever two logarithms are in subtraction with the same base, I can use the quotient rule. So I can write the logarithm once with the base, what I have for the two logarithms, and I have to divide the arguments. That is b times a to the fourth power, c to the fourth power, divided by a to the fourth power. This a to the fourth power, a to the fourth power will cancel out. Then I'm getting log to the base a. So here we have b times c to the fourth power, b times c to the fourth power. So the correct answer choice for this question is option C.